In this video, I'm going to give you an example of how you would solve a direct variation problem that's typically given on a star. So this is a star release problem, and notice it says the total distance in centimeters a toy robot moves varies directly. When you see that varies directly, just remember the way that you find your slope is by placing y over your x value. Then it says with the time in seconds. The toy robot moves a total distance of 264 centimeters in 11 seconds. Now what I'm going to do is I'm going to figure out which one of these is y and which is x. And when you think about x, always be thinking about the input. Frequently is going to be time, and the output is going to be a measure that's given based on a certain amount of time. So in this case, I'm pretty confident that 11 seconds represents my x value, and the 264 represents my y value. In other words, the x is my input and the y is my output. How do I know? Well, because as time passed, a certain amount of distance, right, that was measured as 264. Now when I set up my slope, all right, I'll have m is equal to my y value, so is equal to 264 divided by 11. Now I'm going to use this to create an equation, and I recommend that when you're doing these, always create an equation. So we have 264 over 11, and then I'm going to put variable x here. Next thing I'm going to do is I'm going to look at the last part of the question, and it's going to ask me to find something. So it says, what is the time in seconds? So we're looking at the time in seconds. The toy robot moves when the total distance is 408. So again, notice they're giving me a y value. They're telling me the distance that something has moved. No different than me getting my y value up here, where it told me it moved a total distance of 264 centimeters. So what I want to do now, since they're giving me this value, I'm going to replace my y in my equation with that value that's given. And typically in the first part of your sentence or the first part of the problem, they're always going to give you the x and the y value to create your slope. And then in the last part of the problem, they're going to either give you an x or a y value so that you can solve for the one that's missing. In this case, what's missing is our x. What's missing is the time in seconds it took to move the 408 centimeters. But I'm going to use the equation that I created. I'm going to substitute 408 for y, and then I'm going to bring down the slope that we found by putting our y value over our x. And then I have x right here. Now we're going to use inverse operations to solve this. In other words, this is my coefficient of x right now. Even though it's a fraction, it's just a coefficient. It's being multiplied to the x. So I'm going to go ahead and divide it out to move it to the other side. And I'm going to divide it into both numbers. So it cancels on the right side, and I'm simply left with x is going to be equal to whatever this gives me, 408 divided by 264 over 11. So now what I'm going to do is I'm going to go ahead and I'm going to hit alpha y equals enter to go ahead and get my fraction bar, and I'm going to type 408 in my numerator. And then I'm going to go to the denominator, and I'll hit alpha y equals enter again to get a fraction bar in my denominator, because we can divide by fraction. 264 over 11, and hit enter, and notice it gives me 17. So now I've completed this problem, and I know that at 17 seconds is going to be the time that the y value will be equal to 408 centimeters. So the answer would be G. And so that's how you can use direct variation, right? Set up an equation, go ahead and then substitute for y or x depending on what they're asking you to find, and solve it.